Greetings and welcome. In this section, we are going to work on one of the functions that you find in your exam questions, which is the hyperbola. What I'm going to give here is simply a summary of the hyperbolic function. I've seen some students, they quite rather struggle on this one, but if you master these summary points that I'm going to explain here, then you have mastered the hyperbola function. So in this section, I will explain and summarize on the key concepts that you need to understand. In other words, the characteristics of a hyperbola. And then from there, we are going to use those characteristics to answer one of the questions, one or two questions. So what I have here is the outline of a hyperbolic function or a hyperbola. There are many different types of hyperbola, but the standard one that you will get in most of your exam questions is one that is laid out like this. Now, one thing that we need to know is that a hyperbola, just a definition, they won't ask you definitions, but a hyperbola is just a plane curve that is having two separate parts or branches. Okay, there are more definitions to it, but I will just leave it like that. So what we find here with the hyperbola is that this is the curve. There's a curve over here, and there is another curve over there. So there are two separate parts of the curve. Okay, we describe it as a discontinuous function because somewhere there you'll find along the y-axis there is a line that separates the graph. We are going to give terms to those lines, and there's another horizontal line as well. So our graph looks like it is split along the vertical axis, and it is also split along a horizontal axis. So we now have two separate graphs that we have here, which is curved in that. We call that one the first quadrant. We'll come that in a while, and then the other half there is in the third quadrant. Now, before we get into the details, what we need to know here, understand, is the general equation of a hyperbola. The general equation of a hyperbola is given by the formula y is equal to a over x minus p plus q. Okay, that is the general equation of a hyperbola, where x and y, these are our variables. X is our input. Remember, a function is a relationship in which you put in a value and then you get one output value. So y is our output and x is our input. Now a, p, and q, these are any values. They can be any numbers. E.g., I can have a number here like y is equal to 2 over x plus 1 plus 1. Okay, I can give one equation like that. Or the other one that I can have is y is equal to negative 6 over x minus 3 minus 1. So in these two equations that I have written over here, you will find that both of them, they take this format where y is equal to a. There's a number here on a. We can say here that our a is 2, okay, over x plus 1 plus 1. You can find the value of p. Our P in this case is -1. Okay, I will explain that one. Why we see a +1 here, but I'm saying that P is -1 because in our equation we've got a negative P. The standard equation uses an x minus P. Here we've got an x plus P, which means we are equating negative P to a +1. So meaning that our P is -1. Our Q is 1. Okay, so what I'm explaining here is for us to know the standard form of any hyperbolic function or a hyperbola. So now these letters here, A, P, and Q, these are the most important numbers that we need to understand about a hyperbola. Now, so I'm going to write here, what are the characteristics of a hyperbola? What are the characteristics of a hyperbola? The characteristics of a hyperbola, like I said, is what we see here. There is a vertical line that seems to split our two curves. There is a horizontal line that is also splitting our curve. And we see that our curve is in the opposite ends of these areas, which we call the quadrants. I'll come to that. So all these, what we see here, it can be summarized in the equation. Y is equal to A over x minus P plus Q. So 4 things that we need to define here. 1, in other words, what we need to understand or to draw from this equation. Number 1 is the shape. The shape of the hyperbola. Now, these points that I'm describing here constitute what I refer to as the characteristics. In other words, when you are given a hyperbola or a hyperbolic function, you must be able to notice these aspects or these characteristics of a hyperbola. So one thing that we notice about a hyperbola is the shape. Now, how do we describe a shape? The shape is determined by the value A. Okay, so we can say A determines the shape of the hyperbola. So this number here, A, determines the shape of a hyperbola. Now, how do we describe the shape? Remember when we were covering parabola, we described the shape of a parabola as concave up, concave down. Okay, happy face, sad face, some put it as a cap or a cape. But with a hyperbola, the shape is described in terms of in which quadrant the curve is found. So when we are given A as a positive number, A is a positive number. For example, in the first equation that I have given us, as you can correctly state, our A is 2. So it can be any number here, A is 2. Now we write in maths as A greater than 0. We know that A greater than 0, it means numbers that are greater than 0, bigger than 0. And we are just referring to positive values. So when A is greater than 0, what we have is a situation where the hyperbola lies in the first and third quadrants. Formed by the asymptotes. I'll come to explain what is an asymptote. Okay, so when our a is positive, greater than 0, any number that is greater than 0, we are going to work with the examples. Our shape is described as our hyperbola being in the first and the third quadrants. And these quadrants, they are formed by the asymptotes. Sometimes you may have more quadrants depending on what you are referring to, but in this case we are looking at the quadrants that are formed by the asymptotes. I will explain what are asymptotes. Okay. Then secondly, when our a is negative, less than 0, which means any number that is less than 0, like the second equation that we have used here, our a is negative 6, so it means our a is negative. What does that mean? It tells us that the hyperbola lies in the second and fourth quadrant. The hyperbola lies in the second and third quadrant. Sorry, second and fourth quadrants. This is a fourth quadrant. So it lies in the second and fourth quadrants, formed by the hyperbola, formed by the asymptotes. Okay, so here we are referring to the shape. How do you describe the shape of a hyperbola? We can refer to the shape of a hyperbola as lying in the first and third quadrants, or it lies in the second and fourth quadrants, which are formed by the asymptotes. Now that brings us to the other concept, okay, which is very important in this case. Now we have this term asymptotes, okay, and quadrants. What is a quadrant? Let me explain first of all what is a quadrant. What do we mean by a quadrant? Now a quadrant is, let's say we are going to draw a circle here. When you draw a circle, okay, a circle, and on this circle we draw, let's say, a vertical line like the y-axis and the x-axis, like that. Okay, they will meet at 90 degrees, as we know. This is the x-axis and this is the y-axis. This region here that we have, that portion of the circle, we call it a quadrant. Remember, quadrant, quad refers to 4. So you've got the 4 sections, 4 areas. This one, that, and that. Okay. So you've got 1, 2, 3, 4 quadrants. So when you draw a circle and you draw lines axis from the center, this is the center, we draw like that one. So you have first quadrant. Now in maths, the notation that we use, the rule that we use is this area that I've shaded here, we refer to this as the first quadrant. So we start counting from here, 1, and this one is the second. So we go anti-clockwise. So this is a second quadrant, and this one here is the third quadrant, and that one is a fourth quadrant. So that is the standard rule that we use. 1, 2, 3, 4 quadrants in an anti-clockwise direction. So when we say that the curve lies in the first and third quadrants, okay, we are not necessarily having a circle per se, but now we are looking at this vertical line and that horizontal line. So when we remove the circle, the vertical line and the horizontal line, they create this region. So that region is what we call the quadrant, first quadrant. So what we have is a situation where we have got our hyperbola lying in that area, that is the first quadrant, and another hyperbola lies in that area. So we are saying that when our A is positive, we have this layout of the hyperbola. Our hyperbola lies in the first quadrant and third quadrant. So that determines that. Now, if our A is negative, which means our graph or hyperbola will lie in the second and fourth quadrant. So which means it will lie here in the second and fourth quadrant. So you can see here, I don't have to necessarily write in the circle. So we treat this as the first quadrant, second, third, fourth. So our graph lies in the second and third and fourth quadrants, formed by the asymptotes. That is very important. So we are assuming that this is an asymptote and this is an asymptote. So we are looking at the quadrants that are formed by the asymptotes. So we understand what is a quadrant. Okay, so now let's come to asymptotes. What is an asymptote? So you will find that our graph here, it is special in the way that there are certain straight lines that the graph seems not to cross. Actually, it doesn't cross that line. This is the horizontal one and this is the vertical line. So an asymptote is basically a straight line that constantly approaches this curve. So if you follow that one, it approaches this curve here, our hyperbola, but the curve and the hyperbola will never touch each other. In other words, this curve here, the hyperbola, cannot cross that line. It will never cross either the horizontal line that we have here or the vertical line. So it's basically a straight line that constantly approaches this given curve here, but does not meet that curve at any infinite distance. We can continue the curve, we can continue with the curve, the line, straight line. These two lines will never meet. So that's what we see here. There's a straight line, horizontal, then there is a vertical line. So now our asymptotes then, as we can see from this diagram, is the fact that we have got two asymptotes. There's a vertical line, in other words, a vertical line which our graph cannot cross, okay? Either any one portion of the graph cannot cross this vertical line, it cannot cross that horizontal line. So what we have now is our asymptotes. We have got two asymptotes we have what is called the vertical asymptote. The vertical asymptote, and we have got the horizontal asymptote. Now, the vertical asymptote is given by this letter that we have here. Remember, we are characterizing our equation, right? We said that A determines the shape. Now we are coming to P and Q. P, the value of P that we have here, like here we said that P is -1, and here P is 3. Okay, so those values -1 and 3, they tell us the equation of the asymptotes. So the general equation of the asymptote is given by x is equal to P. Okay, so where P is any value, for example, we can say x is equal to -1. If we take this example that we have here, our x is -1. So x is -1 is our vertical asymptote. Now, what does x equals -1 imply? It means it is a vertical line that crosses the x-axis at -1. Vertical, it means it is parallel to the y-axis. So if I were to draw it here, I will have a line, okay, it is vertical like that. And it will pass at -1. So that will be an asymptote for that. Okay, so the vertical asymptote will be -1. We'll be able to draw another equation here. Actually, let's see, put it down here. Okay, right. So let's put it, leave it there. I think it's fine there. Now, this is we are assuming now this is the y-axis and this is the x-axis. Okay, so this is the x-axis, this is the y-axis. Let's take it that way. And then somewhere here, we've got 1, 2, 3, 4. To the left, -1, -2, -3. Okay, up here, we can have 1, 2, 3. Going below, that is in -1, -2, -3. Okay, just taking 2 divisions here to represent 1 unit. So now, if I am going to use this example that we have here, y is equal to x plus 1 plus 1. Okay, so let's take that example. y is equal to 2 over x plus 1 plus 1. Okay, so our a is 2. Okay, our p is -1. I will explain further what that means. Why are we saying p is -1 here? And our q is +1, which is a 1. We just take that as it is. Now, so we are saying here that the equation x is equal to p. Our p is -1. So the equation x is equal to p. In other words, the line x is equal to -1 represents the vertical asymptote. Now, I'm going to illustrate here where is our vertical asymptote. So our vertical asymptote is that line here, the line that is passing at -1. We use a broken line. Okay, I will use it freehand here. So that is the line y is equal to, sorry, x is equal to -1 is on the left of 0 here. And then the value q represents the horizontal asymptote. So that equation is given by y is equal to q. Okay, our q here is 1, so which means y is equal to 1 becomes our horizontal asymptote. Where is that line? Is the line that is parallel to the x-axis and it passes through 1. So we can draw it like that. Let me use the color for the asymptote there. So we'll find we have got y is equal to -1, and we have got p is equal to, sorry, that is a +1. Okay, so y is equal to 1 is our horizontal axis, so that would represent the q. Okay, and this is the vertical asymptote. So in summary, what are we saying? When you are given the equation y is equal to a over x minus p plus q, okay, a defines the shape. In other words, which quadrant is it? Okay, define the quadrants. P defines the vertical asymptote. Vertical asymptote. Some call it the horizontal shift. Okay, in other words, it looks like we have shifted our y-axis to the left or to the right. Okay, so that is a vertical asymptote, and the q represents the horizontal asymptote. Which is sort of the vertical shift, whether you're going up or down. So in this case, implying we have shifted the x-axis either up or down. So our q can be negative. If it is -1, so it will be a line over here. So what we have discussed here is very, very key. Now, the next thing that we have to look now in this equation, the equation that we are using here, this equation, is the fact that we have to look now at 2. Okay, 2, remember, is our a. It represents the shape. Now, in which quadrant is our hyperbola? You know, those two curves. In which quadrant is it? So 2 is a positive number. A is greater than 0. So you will find that our graph rather is in the first and third quadrant, like we mentioned earlier here. When a is positive, is in the first and third quadrant. So now what it tells us that when you look at the quadrants, remember when we say first and third quadrants, we are looking at the quadrants that are formed by the asymptotes. So here, look at our asymptotes. Look at the asymptotes here. Okay, these red broken lines, dotted lines. So that is our asymptote. Therefore, which quadrant do we have here? We have got a first quadrant here. So you find that. So it means our curve is going to lie in that. So we can actually draw our curve inside here. Remember, an asymptote, our graph cannot cross the asymptote. So it is a line that approaches there. Okay, it's a curve. Then it will come down. Okay, For now, I'm just estimating. We'll talk about the y-intercept. It is crossing there. We are not sure yet. It is crossing at 2. So then it will come and approaches like that. So where am I drawing it? I'm drawing it in the first quadrant. The other quadrant, the other curve will be in the third quadrant over here. So we can draw our curve like that. Now, you have to pardon me here because the assumption is that our graph is going to cross at 2, but that's not it, because I'm just illustrating here. Those points, this point is a y-intercept. That's one of the characteristics that we need to define as well. Now you will find that the graph that we have here has got a y-intercept. What is a y-intercept? A y-intercept is a point, the value of y, where the curve crosses the y-axis. So we will find that it is crossing over here. So actually, that's one thing that we need to state when it comes to the graph. The graph also has got intercepts, the y-intercept and also the x-intercept. So when we are working with a hyperbola, to summarize that, when we are working with a hyperbola, remember we are trying to characterize or to give the characteristics of a hyperbola. When we summarize that, there are four things that we need to define. Number one, 4 things, is the shape. Okay, is the shape of the parabola. How do we determine the shape? When a is greater than 0, then it means our graph is in the first quadrant and third quadrant. Okay. Number 2, when our a is less than 0, our graph is in the second and fourth quadrant. Secondly, we are now summarizing the hyperbola. We have also to refer to the asymptotes. A hyperbola has got asymptotes. Now, how do you find asymptotes? There are 2 asymptotes. The line x is equal to p is our vertical asymptote, and the line y is equal to p is our horizontal asymptote. Where are we getting our a, p, and q? Actually, this is a q. Okay, y is equal to q is our horizontal asymptote. Where are we getting our a, p, q? We get it in the equation y is equal to a over x minus p plus q. The third one is the intercepts. The intercepts. Now the intercepts, remember, we have got the y-intercept, just like in the parabola. And how do we find the y-intercept? We let x is equal to 0. Okay, in other words, we substitute x with a 0 in our original equation. Like here we've got the equation y is equal to a over x minus b, so we can have that as a 0. Okay, the other one is the x-intercept, finding the x-intercept. In most cases it's 1, so we let y is equal to 0, substitute y is equal to 0. Now what we have mentioned here, okay, in this section summarizes the hyperbola, this function that we have given here, y is equal to a over x minus p plus q. Now let's get into one of the examples that we have here. This is November 2011 question paper, just to practice now, put into practice what we have been explaining, discussing earlier in this. Now this is a typical example of a question that we are given. So we are given, consider the function f of x is equal to negative 6 over x minus 3 minus 1. Okay, we'll give you here number 5, 1.1.1. We are given f of x is equal to negative 6 over x minus 3 minus 1. So what we see here is the general equation of a hyperbola, which we know f of x refers to y, so which we can write as y is equal to negative 6 over x minus 3 minus 1. From this, even before we get into the questions, we should be able to characterize this graph in order to explain the nature of the hyperbolic function. One, let's look at our general format. Once more, it says y is equal to a over x minus p plus q. Now what does that tell us? Our a is negative 6. Okay, so if our a is equal to negative 6, which is negative, our a is less than 0. So what does that tell us? It tells us that the graph will lie in the second and fourth quadrants. Our a is negative. Okay, what is our p? Our p is negative 3. Sorry, our p is 3, positive 3. Okay, so what does that mean? X is equal to p, which means x is equal to 3, is our vertical asymptote. Is our vertical asymptote. Okay, what is our q? Our q is negative 1. Okay, q is negative 1. So when q is negative 1, it means that the line y is equal to q is our horizontal asymptote, which is negative 1. The line y is equal to negative 1 is our horizontal asymptote. So that's what we can draw from here. Now, most students, what I found is when it comes to giving the p-value, now they see an x minus 3, and when we say what is p, the most they will say p is negative 3, because what we see here is a negative 3, which is not correct. Okay, remember our equation is in the form y is equal to a over x minus p plus q. And what do we have here? We have our equation. The original equation is y is equal to negative 6 over x minus 3 minus 1. The p in the standard equation is a negative p. Okay, it's a negative p. So in actual fact, we are equating negative p, equating it to negative 3. Okay, so when we divide, we'll find our p will be equal to 3. So that's why we say p is 3. Now, or another way which you can use to find the value of p is the fact that we want to find the value of x that will give this denominator a value 0. In other words, what is the value of x that will give us a 0 over here? Okay, in other words, we want something like minus 6 over 0, because a negative 6 divided by 0 becomes undefined. So we can say that when x is 3, coming here, when x is 3, okay, our equation is going to be y is equal to negative 6 over 3 minus 3 minus 1. Now 3 minus 3 will give us a 0. That will give us y is equal to negative 6 over 0. Now negative 6 over 0 is undefined. We don't have a value for that. When you punch it in a calculator, that will give us an undefined. Okay. In other words, we are saying that when x is 3 over here, we don't have a value for y. That's why x is equal to 3 is our asymptote. That's why we are getting a 3 there. So, in other words, when we are given a value here, x minus 3, okay, in other words, you are looking at the value of x that you need to put in there to give you a 0, a denominator of 0. That x is the vertical asymptote. So which means if you are given y is equal to, let's say 7 over x plus 3, okay, minus 1. I'm just giving you an example. So what should be our x here? We want to make this denominator a 0. So my x cannot be 3, because if I add 3 plus 3, I'll get a 6. So to get a 0, my x must be a minus 3, negative 3. So what it means is my x should be negative 3 is my asymptote. That is the vertical asymptote. So that's what we needed to draw from there. Now let's come to the question once more. So we were just trying to analyze the graph and characterize the graph before we get into the question. So my emphasis is that when you are given an equation of a hyperbola, you must understand the different characteristics of that hyperbola rather. Okay, so know the shape, the x intercept, the y intercept, the vertical asymptote and the horizontal asymptote. So that's what we have here. Now let's come to the questions now. The question 1 is saying 5.11, calculate the coordinates of the y-intercept of f, that is 2 marks. So this is our equation. F of x is equal to negative 6 over x minus 3 minus 1, and our y is equal to negative 6. We can just write f of x as a y for the purposes of substitution. Well, so we can write it like that. And now remember, to find the y-intercept, we let x is equal to 0. So substitute x is equal to 0. So to solve that one, we are going to say, we are going to calculate here. Our y is going to be negative 6 over, let x means substitute x with a 0. So we're going to have 0 minus 3, that is negative 3, negative 1. And which gives us a negative negative, that is a 2 minus 1, that is a 1. So the y-intercept is 1. Remember, earlier we mentioned that intercepts are also part of a hyperbola, where the graph, the curves will cross the y-axis. So it will cross at 1. Okay. Number 5.12, calculate the coordinates of the x-intercept of f. So x-intercepts, where does it cross the x-axis? We let y is equal to 0. Let y is equal to, substitute y with a 0, or f of x is equal to 0. So equate f of x is equal to 0. Now you take your function and equate it to 0. So what is our y? Y is equal to 0. Write a 0 here. 0 is equal to negative 6 over x minus 3 minus 1. Okay, to solve this one, take the negative 1 over. We have 1 is equal to negative 6 over x minus 3. Okay, we can cross multiply here. So I'll get, therefore, x minus 3 is equal to negative 6. Okay, therefore, our x is equal to negative 3. So our graph is going to cross at negative 3 on the x-axis. And then the question asks here, sketch the graph of f in your answer book, showing clearly the asymptotes and the intercepts with the axis. So that's where we are going to draw our graph. So we can draw our graph here. So let's put our graph. So in this one here, this is our x-axis, that is our y-axis. Right. Now we need to take note of all that we have discussed now. Number one, what we need to insert here are the horizontal asymptote and the vertical asymptote. So where is our asymptote? The value 3 is the vertical asymptote, which means the x is equal to 3. Now that's we need a 3 here to make a 0. So x is equal to 3 is our vertical asymptote. So we will have to draw a vertical asymptote here. That is my 3. Draw it nicely with a ruler. I'm just using freehand here on the screen. Okay, so that is the line. X is equal to 3. It's on the positive side of the x-axis. Where is my asymptote, the horizontal asymptote? The horizontal asymptote is negative 1. Y is equal to negative 1 is the horizontal asymptote. And This line is somewhere here. Okay, so that's where we are, and our x-axis is 0, and this is the line y is equal to negative 1. Y is equal to negative 1. Use your broken lines, dotted lines like that. Now, remember, they are asking us to sketch to show the asymptotes and the intercepts. Now, that brings us to the concept of shape now. Now, our A here, as we mentioned earlier, our A is negative 6. So that means our graph is going to be lying in the second and fourth quadrant, formed by the asymptotes. So over here, you will find that these are our asymptotes there. Now, this is the fourth quadrant, so which means my graph, part of the graph will lie here. Okay, we are assuming that this is a vertical asymptote that will continue. So the part of the graph will lie there. That is the fourth quadrant of the asymptotes. Now, the second one, the second is lying in the second quadrant over here. Now here, when you draw, you'll find that this curve will cross the y-axis and the x-axis at the same time. But now how you draw it, you must be careful, because you can make it cross on the right side, on the positive side of the x-axis from 0 here. Okay, I can draw it like that. I'm just illustrating. Or I can draw it like that. Now, which scenario would be correct here? Y-intercept is there, and the other x-intercept is here. Okay, so now it means that when you are drawing, your graph should cross on the positive side of the x-axis, of the y-axis, and the negative on the x-axis. So in short, we are saying when you are drawing, we have drawn the first curve in the fourth quadrant. Now, when you are drawing the other portion, take note of your again, I'm going for asymptotes. Take note of your intercepts, okay? Y is equal to 1, the y-intercept. So it is going to cross at 1, which means somewhere on the positive side, okay, of the y-axis, and the x-axis, the x-intercept is on the negative side, which means that our graph should cross like that and approach our intercept. It will never touch that line, where this point here is our y-intercept 1, and that one here will be our x-intercept, which is on the negative 3. So that would conclude the drawing of the graph. So we'll find there is a there's a y-axis here. Okay, there's an x-axis, vertical asymptote, x is equal to 3, horizontal asymptote, and our shape. Okay, so to summarize all that we have done here, the characteristics of a hyperbola, number one is the shape. Number 2, asymptotes. which are x is equal to p, y is equal to q. Number 3, we need to determine the intercepts, which are the x-intercept and the y-intercept. We also have the line of symmetry. Okay, the hyperbola has got 2 lines of symmetry, but I will not cover it in this video. There's a separate video, we'll cover that one. There is a line of symmetry. How do you work with the line of symmetry of hyperbola? In other words, there's a line that divides our hyperbola into 2 equal parts. So actually there are 2 lines of symmetry. There's one that divides along, it passes through the intersection of the asymptotes. So it goes like that. Okay. And there's another equation that goes like that. So those are the other parts of the hyperbola. We also have questions to do with the range. How do you determine the range? And how do you determine the domain? So you can add it to this. Number 4, the axis of symmetry. Axis of symmetry. There is also the 5th one, which are the range and the domain. Okay. So that brings us to the end of this section, and follow the other video that I'm going to post on how do you determine the axis of symmetry and how do you work with questions relating to the range and the domain of a hyperbola. Thank you for watching. Until next time, goodbye.